Okay, welcome back to part 2 of our centers of triangles. This example is going to be working with the angle bisectors. And it says if a point lies on the angle bisector of an angle, then it is equidistant from the sides. Okay, so it's equidistant. That means the side is equal to the side, and it's perpendicular because that's going to be the shortest distance between that point and the side. Okay, so it says find x and y. So if I look at x, I'm dealing with the angle bisector piece of it, and that means that the angle bisector splits the angle into two equal angles. That means 7x plus 17 is equal to 3 times 4x minus 1. So if I want to use that technique I used in the last example, I have 17 and 7, and I'm looking at 3 here to see if I can divide it out, and I can't because 3 is not a factor of 7 or 17. So I do need to distribute in this problem. 7x plus 17 is equal to 12x minus 3, because I take that 3 and multiply it to everybody inside. And then, like I said before, I like to take my smaller x and subtract it from my larger x. That keeps them positive. And I get 17 is equal to 5x minus 3. Add 3 to both sides. I get 20 is equal to 5x. Make sure to carry that up. And then divide by 5. And x is equal to 4. Okay, if I want to go to my y's, I'm going to be using this angle bisector theorem that says if I have a point on the angle bisector, then it's going to be equidistant to the sides of the angle. Equidistant means they're equal. So I know 8 is going to equal 2y plus 4. And then I can solve for y. I'm going to subtract 4 from both sides. I get 4 is equal to 2y, and then I divide by 2. And my y is equal to 2. Okay, so the important thing here is if you have a point on the angle bisector, then it's going to be equidistant from that point to the sides. Then we have centroids, and centroids are created from the medians. And what's unique about the centroid is if I were to take this triangle and cut it out, and I put my very sharp pencil point right there at point G, did you know it would balance perfectly? That's what the centroid is. It's the balance point of the triangle. So here we have G is the centroid. That means it's made up of all the medians intersecting. And I'm given that GD is equal to 27. What is GB? Okay, well, if we look at our properties of a centroid, if I go from my median to the vertex, that is 2/3 of the side. Okay, it's right here in pink. 2/3 of the side, or of the length. That means that 27 is 1/3 of the length. So multiple options here. If GD is 27, and that represents 1/3 of it, and I have GB that represents 2/3 of it, then I can take 27 and multiply it by 2. Because if this is 1/3 and I need 2/3, so I need 2 of them, that would make it 54. Or I know that 3 of the 27s, since it's 1/3, is equal to 81. That would be the entire length of the segment BD. Then I could take 81 and I can subtract the 27, and that still gives me 54 for GB. because I would be taking the whole length and subtracting this piece to get the missing piece. In the next example, we're given G is the centroid and GA is 48. What is the whole length? Since GA is going from the vertex to the centroid, that represents 2/3 of the length. So 48 represents 2/3 of the length. So if I half that, that gives me 24. That represents 1/3 of the length. Then if I have 2/3 and 1/3, I can add those two together, 48 and 24, and that gives me 72. And that would equal AF. And this concludes our application of our centers of triangles.